Hello, my name is EDoami, and today I'm going to be teaching you about balancing chemical equations. So, why do you need to balance chemical equations? It is because of the law of conservation of mass, which means for any system closed to all transfers of matter and energy, the mass of the system must remain constant over time. And how can you use the balanced chemical equation? You can use it to find the molar ratio between reactants and products, and it is also used in stoichiometry. Here is how you balance a chemical equation. First step, write down the original unbalanced equation. So we will be using CH4 plus O2 makes CO2 plus H2O. Step 2 is to write down the amount of each element on each side of the reaction. For our reaction, on the reactant side, there's 1 carbon, 4 hydrogen, and 2 oxygen. On the product side, there's 1 carbon, 2 hydrogen, and 3 oxygen. Step 3 is to trial and error multiplying certain reactants and products until the amount of each element on both sides of the equation is equal. A tip is to manipulate the larger reactants or products first and end with the smaller reactants or products. For our equation, you can first start off by multiplying the number of hydrogens on the product side by 2, making it 4 hydrogens on the product side. Since you multiplied the number of hydrogens by 2, you have to multiply the amount of H2O by 2 as well, meaning you put a coefficient of 2 in front of the H2O. This also makes the amount of oxygen 4 on the product side. After, you can multiply the number of oxygens on the reactant side by 2 to make the number of oxygens 4. Since you multiplied it by 2, you put the coefficient 2 in front of the O2. You do this because you want the number of oxygens to be equal on both sides. So now, when you count the amount of each element, there is 1 carbon on both sides, 4 hydrogen on both sides, and 4 oxygen on both sides. Since they have the same amount, the equation is balanced. Now it is time for more examples. The next example is C3H8 plus O2, which makes CO2 plus H2O. The second step is to count the number of each element on both sides. So the reactant side, there is 3 carbon, 8 hydrogen, and 2 oxygen. On the product side, there is 1 carbon, 2 hydrogen, and 3 oxygen. The next step is to get the equal amounts of each element. So you can start off by multiplying the number of carbons on the product side by 3, making it 3 carbon. Since you multiplied it by 3, you put the coefficient 3 in front of the CO2. This makes the number of oxygens on the product side 7. Now there are 8 hydrogen on the reactant side, but 2 hydrogen on the product side. You can multiply the hydrogens on the product side by 4, making it equal to the reactant side. This means you must put the coefficient 4 in front of the H2O. This also makes the number of oxygens on the product side 10. Now there are 10 oxygen on the product side, but 2 oxygen on the reactant side. You can multiply the number of oxygen on the reactant side by 5 to make both sides have 10 oxygen. Since you multiplied the number of oxygen by 5, you have to put the coefficient 5 in front of the O2. Since you didn't do anything to the carbon or hydrogen on the reactant side, you put a coefficient of 1. When you recount the number of elements, they are equal on both sides, which means the equation is balanced. Here is the final example I will go over with you. It is Al plus Fe3N2, which makes AlN plus Fe. When you count the elements, there is 1 aluminum on both sides, 3 iron on the reactant side, and 1 iron on the product side. And then there's 2 nitrogen on the reactant side and 1 nitrogen on the product side. You can start by putting the coefficient 2 in front of the AlN, which multiplies the number of aluminum and nitrogen by 2 on the product side. This makes the amount of nitrogen on both sides equal. You can then multiply the amount of iron by 3 by putting the coefficient 3 in front of the Fe. This makes the amount of iron on both sides equal. Last, you can put the coefficient 2 in front of the Al, which makes the amount of aluminum 2, which is the same amount on the product side. Since all elements are equal, the equation is now balanced. Now it's time for your own practice problems. A is NaClO3, which makes NaCl plus O2. B is Fe2O3 plus C, which makes Fe plus CO2. Do these questions on your own and then come back for the answers. Here are the answers to your practice problems. A was 2NaClO3, which makes 2NaCl plus 3O2. B was 2Fe2O3 plus 3C, which makes 4Fe plus 3CO2. I hope you learned how to balance chemical equations. Thank you for watching.